the first problem I gave you, when you take the derivative of square root of x. So the derivative of square root of x is 1 over 2 square root of x. How many of you understand this immediately? Take the derivative of, say, natural log of secant x. So what will be the derivative of natural log of secant x? So this one will be 1 over secant x, and then the derivative of secant x will be secant x tan x. Do you see that? And then secant x will cancel out. Your answer is tangent x. This is derivative. Now why I am giving you these two examples, you will see in my next problem, and it is coming from here. For example, square root of x, you know the exponent is 1/2, right? So when I use the power rule derivative, so this 1/2 comes in front, and then x to the 1/2 minus 1. This is the power rule of derivative. So that one is giving me 1/2 x to the negative half. So x to the negative half meaning is it is going in the denominator. And then we say 1 over 2 square root of x. And that's the reason I said you remember this one. And then what is the benefit of knowing this? I'm going to the next step now. Integration of, say that sine square root of x over square root of x dx. Okay, so if you want to do this integration, you need to use the substitution rule, where we say u equals square root of x. When you say u equals square root of x, then you get sine u in the numerator. Then what happens? I need to take the derivative of these, which is du dx, and I know that the derivative of this one is 1 over 2 square root of x. Now from this clearly you see 2 du is 1 over square root of x dx. So that is the quantity I have remaining here, 1 over square root of x dx. That's my 2 du. So then I can just say that my problem is now reduced to 2 times sine u du. It's a simple integral now. So the integral of sine u will be negative cosine u plus a constant. So we get negative 2 cosine square root of x plus a constant, and you are done. Did you see the connection? Integral 8 sine square root of x over square root of x dx. Now see that? So when you apply the method I have explained, will be like this. This 8 is a constant, keep outside, and we have used u equals square root of x, and we have found 1 over square root of x dx is 2 du from the previous example. So then this one becomes 2 sine u du. That means you have 16, and integration of sine is negative cosine u. See how fast you can solve your problem? So you get negative 16 cosine square root of x plus c. This is very fast now, if you know some basic ideas. Second one was this. Derivative of natural log of secant x. This one, remember, our answer came out like tangent x. Remember from my example? Number 2 is this one. Now we have a problem here. It's coming out integration of tangent x dx. How do we do this? If you know this result, then immediately you can see that it is natural log of secant x plus a constant, because the derivative of this one is tan x, so integral will be this one. Now suppose I don't know, how do I approach this problem? Then you will do like this. Integration tangent x dx, you say integration tangent x, we know from trigonometry, the sine x over cosine x, isn't it? That one. And then what we do, go with the substitution rule. Say that u equals cosine x, the one here. I call this is u. Then my du will be negative sine x dx. So then this negative you can move on the other side. So then sine x dx is my du. So I'm getting integration 1 over u du. And this is a simple integral. We know that 1 over u integration will be, I have a negative in front here, minus natural log of u. And careful with your absolute value sign. You must put absolute value sign, otherwise you will have domain issue. And I will explain you what is domain issue. So then further simplified version is giving me negative natural log of cosine x plus c. This answer I can keep, this answer, and the answer I have written natural log of secant x equivalent. And you see how. Natural log, this negative I can put on the exponent of cosine. So I can say cosine x to the negative 1 exponent. So cosine x to the negative 1 exponent is actually 1 over cosine x, isn't it? So what is 1 over cosine x? Is secant x. That's why I have written answer as secant x. Okay? So you are done. So you have seen how these results are coming. If you know from derivative, you can plug it immediately. But if you don't remember, then make little manipulation like this, tangent x sine over cosine, and then go with u substitution. So when you write natural log of x like this, the graph is this one, only right side. So in this case, my x is greater than 0. But when I write natural log of absolute value of x, my graph will be this, also this side. So in this case, your domain is only x cannot be 0. Left side, right side, both positive, negative, I can take. See the difference? That's why when I'm taking integration, and you have seen integration of 1 over x dx, just look at here. When I have 1 over x, what is the domain? Domain is x not equal 0, isn't it? Negative positives are okay. But when I'm taking this integral result, that is coming out as natural log of x, and you see that it goes here. Still this domain is preserved.